All right, hello once again, Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD, or Application and Web Development 1100 C# programming class, I've been doing a series of video presentations, mainly based on the book for our online class, that being Muroc's 8th edition, C# 8th edition. But I've also, the PowerPoints for that book, and I've also been doing a couple projects. Okay, so far we've gone through all of the intro, section 1, all of section 2, the C language essentials, and now all of section 3 on object-oriented programming. I did skip chapter 13, just so you know, and we're going to jump up to chapter 4, or section 4, chapters 17 and 18. All right, in fact, we've done 17 already, so we're going to look at chapter 18. But we're also going to go back and forth between chapter 18 and chapter 19. And the reason for that is for you to be able to understand LINQ, in my opinion, you first need at least a little bit of an explanation of databases. So I'm going to kind of bounce back and forth between the two chapters. Maybe I'll even do 19 first. Then I'm going to build 2 or 3 apps, full apps. One of them will build as both a console app, and then we'll go back and we'll rebuild it as a GUI app, and the other one we'll do as a GUI app. And we're going to do those both, hopefully at least, using databases and using LINQ. All right, if I can get done with all that stuff, then tomorrow my hope is I can jump into 20, 21, and 22 and get as much of that done as possible. So with that said, I'm going to jump into 18 and 19, and I have the PowerPoints for both 18 and for 19 up here. Let's start with 19, all right? So let's start with an introduction to database programming. All right, here's our objectives. They're all knowledge objectives. Describe the hardware components and the software components of a typical multi-user system, or for the hardware, and a multi-user database app for the software. Number 3, explain how a table in a relational database is organized. Number 4, explain how tables in a relational database are or can be related. Number 5, describe the use of what we typically refer to as CRUD, create, read, update, and delete. Create here, they're using the word insert, and read here, they're using the word select. Okay? All right. So this is a typical client server type of system. If you'd have seen this book, probably 10 years ago, you wouldn't have seen a phone on there. You wouldn't have seen a tablet. It would have been laptop or desktop, laptop or desktop, laptop or desktop. This network that you see here is basically what we all call the cloud. All right? It's the internet. And then you've got a database server over here. So the 3 components, as they mentioned there, are client, server, and the network. The clients are whatever computers in the system that are being used to basically get information from a server. And again, that can be a tablet, that can be a phone, that can be a laptop or a desktop, or possibly even something else. The server, as it says there, is a computer that stores the files and the databases of the system, and it provides necessary services. The network are the connections. It's the cabling, the communication lines, etc., that connect the clients with the servers. All right. As it says here, in a typical client-server system, the server communicates with clients over a LAN, a local area network. Case in point, if you are either at the St. Louis campus or you're at the Wentzville campus, the machines that are in the IT area, the information technology area, are hooked up to one another, and they're hooked up to a server as well. They're set up in a LAN or local area network connection. However, there is not a direct connection between the machines at Wentzville and the machines in St. Louis. That's 40 miles. So there, All right. The LANs can be connected using a wide area network or a WAN. All right. When a system uses a private network and servers over a wide area, it's typically called an enterprise system. So what we have here is a diagram with all this stuff in it. So the client, and again, that can be a phone, that can be a tablet, it can be a laptop or a desktop, queries a database server someplace. If possible, the server comes back and provides the results. So the client, as it says, utilizes application software and a data access API. An API is an application program interface. It's a way, in this case, for two bits of software to communicate with one another. The database server uses a NAS, or a network operating system. It also uses a DBMS, a database management system. The database management system we'll be using in this class is called SQL Server. Some server terms. As it says, to manage the network, the server runs a NAS, or a network operating system like Windows Server. To store and manage the databases, the server requires a DBMS, or a database management system. What's done by the DBMS is typically referred to as back-end processing, and it's back-end because you don't normally actually see what's going on. The server itself is oftentimes referred to as the back-end. For some client terms, as we see here, the application software does the work the user wants to do. This kind of software can be developed in-house, but more often than not, it's going to be purchased. All right. All right. The data access API that we talked about a little bit earlier provides the interface between the application software and the database management system. This processing is typically referred to as front-end processing. You actually are doing the communication here. Microsoft's data access APIs are typically the ones that are used most often are EF, Entity Framework Core, and ADO.NET. ADO is another acronym for ActiveX Data Objects. The SQL interface, as it says right here, the application software communicates with the DBMS, and it does this through the use of queries. It asks questions to the database. It does this through the data access API. When the database management receives queries, these queries can typically just provide information or change data that's in the database by updating it, or by adding new data, or by removing existing data. All right. So as it says, when the DBMS receives the query, it provides a service like returning the query results to the client. SQL is a language that's used for working with relational databases. There are other relational databases. Let me say that again. There are other databases that are non-relational. All right. So here's the way. So it says this, for example, we're going to have in our program that we're working on, we're going to have a products table. All right. And if you look in here, this products table has a couple things. It has 4 columns or fields: product code, description, unit price, and on-hand quantity. So it's 1, 2, 3, 4 fields, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 records in here. Each line across that you see is a record. So the first record that's in this database has a product code of Android, a description of Murox Android programming, a price of $57.50, and an on-hand quantity of $37.56. And you can figure out the rest by hopefully taking a look there. So when you work with relational databases, you use tables to store your information and to be able to manipulate that information. Each table, as it says, consists of one or more records or rows that contain the data for a single entry. All right. Each row contains one or more fields or columns. Most tables contain a primary key. Keep it simple. A primary key is typically referred to as a unique record identifier. Some DBMSs let you define one or more non-primary keys. I'm not going to worry about those for now. In SQL Server, non-primary keys are called unique keys because they're implemented using unique key constraints. We'll get into all that stuff. And a table can be defined with one or more indexes. All right. The primary key automatically has an index set up for it. So again, when you look at this, each one of these, let's see, I don't know if it's going to let me draw on here or not, but I'm going to try. Well, it made it white. But what you see right there, that is a record of information. That is a record right there. Okay? So that is a record of information. This, don't want to do that. Still don't want to do that. So this is a column of information. All right? So we're talking rows and we're talking columns. All right? Now, you also should notice that two of these fields in here, those being the product code and the description, basically they're strings. The price is basically a decimal, and the on-hand quantity is an integer or whole number. So typically what you want to do when you're working on this stuff is you want to be able to come in and relate these tables together. What does that mean? That means if you look in here, all right, we've got an invoice table and we've got an invoice line items table. All right. And if you look in here in the invoices table, each invoice ID is unique. This is going to be the primary key right here, right there. In here, we don't have anything that's unique. Python, 5750, 5750, 11, 5750, 5750, 46, 46, 46. So it's pretty easy to figure out the primary key in here, but how do you figure it out in here? The answer is you combine two fields together. So the primary key becomes what's called a concatenated primary key. All right. And it is a combination of the invoice ID and the product code, because notice 46 ASP MVC, 46 C#, 46 HTML, 46 SQLS, 47 ASP MVC, 47 C#. All right. So how are these tables actually related to one another? All right. They're related through their keys. So you'll notice invoice ID is in both tables. All right. A column that identifies that's in one table that identifies a related row in another table is called not a primary key, but a foreign key. All right. The table with the foreign key is the foreign key table. The one with the primary key is the primary key table. All right. And it says the most common relationship is a one-to-many. Well, what do we have here? Every one invoice has 0, 1, or more line items. So this is the one, this is the many. Tables can have not only one-to-many relationships, and that's what you strive for, but they can also have one-to-one relationships and one-to-many relationships. Okay? Now, they're jumping right into this. This is the SQL Server Object Explorer design view window. So you can come in here and you can go in and you can create these kind of tables yourself. And I'm going to show you how to do that. All right, in a little bit. You'll notice again, for instance, okay, 1, 2, 3, 4, 5, 6, 7 fields. Invoice ID, which looks like a number, customer ID, which looks like a number, invoice date, which is a date time field, product total, which is a decimal field, sales tax, which is a decimal field, shipping, which is a decimal field, and invoice total, which is a decimal field. And when you look in here, okay, now they're actually using the word money because we are working with money here, but those are decimal fields. Invoice ID and customer ID are both ints. Invoice date is a date time, and the rest are money fields. Here's some of the data types that you can use in here. Don't worry about memorizing. Okay. These that are right here, those are strings. All right. Char is a fixed number of strings, or nchar. Varchar is a variable number as far as the number of characters in the string. Then notice there's a date, a time, and a date time. Decimal and numeric, float and real, bit, big int, small int, and tiny int, money and small money. All right. Now, one of the things, I just want you to see this. All right. We're about 65% or so of the way through the chapter. And you have seen this kind of thing before. But, one of the things that I'd mentioned to you is that if you go out to w3schools.com and you go to the tutorials, all right, you'll notice if you go up here high enough, there's, well, someplace in here. So let's go to here, tutorials. There is one for C#. There it is. All right. But also, just so you know, if we again go back here, there's SQL. We can also get there from tutorials. And somewhere in here will be SQL. I don't know where it is, but let's look. There it is, Learn SQL. Right there. So there's a tutorial on that as well. All right. I would highly recommend it as we go through this, if you're having problems with anything, that you take a look at the tutorial for C# and or the tutorial for SQL. Now this, it's not perfect, but it's pretty much, this is a database diagram right here of the books database that they're going to use in the text here. Now, the only thing I think personally that they screwed up on is if you look at the order options, it's not linked to any of the other tables. It's kind of an island. It's sort of out there on its own. I don't think that's a good thing, but that's just me. All right. You'll notice if you go here, you've got customers and invoices. And then there's a key. And then there's a thing there that looks like an 8 sideways. So the key is the one side, and the sideways 8, which is an infinity symbol, is the many side. So that means one customer can have 0, 1, or many invoices. One state can have 0, 1, or more customers. One invoice can contain 0, 1, or more line items. All right. One product can be associated with 0, 1, or more line items. All righty. So they're going to show you how you can write some queries in here. We're going to do this. In fact, what I'm going to do is a couple things. All right. First, I'm going to show you in a little bit one way that you can come in here and start to write these queries almost like that. Okay, almost like that. All right. And I'll even bring in the database that they have in our book. This is a select query. This says what I want is I want you to go out to the customers table and I want you to select every customer name and the city they come from, but only where the state is equal to Washington. And then put them in ascending order based on name. So look at what we get. All right. Notice they're in order based on name. Allen, Antilaki, Casara, Giraka, Hester, Howell, McMillan, Millard, O'Neill, Severs, Smith, and Sundrum. If we had put them in order based on city instead of based on name, all right, you would have had what? Kennewick, then Kirkland, then Mount Lake Terrace, etc. All right. This is some terminology that you can use when you actually go through and start querying or looking at a table. All right. The result of you doing this and working on a table, it's called a result set. All right. The select clause that you use, it lists whatever you want to have included. If you want everything that's in the customers table, you don't need to do this. You can say select followed by an asterisk, and that'll show you every column in that table. The select list, as it says, lists the columns to be included, which can include calculated columns. We won't worry about that for right now. The from clause names the table where the data will be grabbed from. The where clause allows you to do filtering. It allows you to provide a condition that you can use that must be met for the rows that you want to have retrieved. If you don't have a where clause, again, it'll bring in everything. The order by allows you to put something in ascending or descending order. The default is ascending. And as I mentioned, to select all columns, you put an asterisk in there. So you look at this, they've jumped into something pretty tough here. I mean, what the heck is this? What they're doing here is what's referred to as a table join. They are grabbing information from two different tables. They're grabbing information from the invoice line items table and the products table. All right, in order to be able to do that and get information from two tables like that, the two tables must have one or more fields in common. So you'll notice that the invoice line items has a product code field and the products has a product code field. All right, so they both do. And then there's a where. So you want to join in on that, but only if the ID for the invoice is 46. So you'll notice if you look at the result of that query and we go to the invoice ID, it's the same for each one. In fact, this that you see right here was these four that are in here. All right. Sometimes when you get working with this stuff, it can really be tough because you've got long table names and long field names, etc. So if you so desire, you can go in and actually do what are referred to as aliases. So what I'm saying is, anywhere we said the word products, Now I can just say P. So instead of products.product code, which is what we had here, products.product code, since I've aliased products with a P, I can now say P.product code. For the line items, I changed the name to LI. So that's line items dot, etc. for all these. All right. When you combine information together from two or more tables into a single result set, it's known as a table join. The table join you're going to use probably more than 90% of the time is what's called an inner join, sometimes called an equijoin. This type of join, as they mentioned there, returns rows from both tables, but only if there's a match. And you're going to see this in just a few minutes. You can make your SQL statements more readable by using aliases. We just looked at that. All right. Here's how you can add an item into the products table. What are we adding? We're adding something with a product code that's R, with a description that's Murox R for data analysis, with a unit price that's $59.50, and with an on-hand quantity that's 3,000. Here's how you can update or make changes to an existing record in a database. Update product, set unit price to $54, where the product code is MySQL. If you leave this off, let's say that I didn't put this in, that you see in gray there. Let's assume for a second that all I put in here, the only thing I put in here was update product, set unit price equal $54. Then that would change the price of everything to $54, not just those with a product code that's MySQL. This is a delete. This basically says delete customer with ID 558. And again, if we leave this off of there, if we leave that off, what's going to happen is, all right, if we leave that off, that'll delete all customers from the database. All right, that's it for this. Went even faster than I thought it would. That's 28 minutes. So let's do this. Let's go back to the start, and now let's go over to Chapter 18. Chapter 18 is on how to use LINQ. Well, first of all, what the heck is LINQ? LINQ is an invention by Microsoft that basically allows you to do the equivalent of database queries on almost anything. Not just databases, but arrays, lists, and other things. So you can perform database-like operations on things that are not databases. Now, you can use LINQ with databases, but you do not necessarily have to. All right, now that I think about it too, this might be too hard, so what I'm going to do is I am going to break this thing up into 2 lectures, so I'll be right back.